Welcome back. Let's do some mole conversions. Now we're going from moles of a formula compound to moles of an atom. All right, and we use the subscripts in the chemical formula. All right, let's take a look. So in part A, we're interested in hydrogen. Now we have this formula, H3PO4, and we are interested in this 3 here. We know that there are 3 moles of hydrogen in this chemical formula. So to do the conversion, we are starting out with 2.00 moles of H3PO4, which is phosphoric acid, in case you're wondering what that substance is. And we do the usual dimensional analysis. We've created our fraction bar there. And for the moles of H3OP4 to cancel, we would need that to be on the bottom. And this is the best way to show the work. And up on top, we have 3 moles of hydrogen. Now, the 3 and the 1 here are exact numbers from this chemical formula. So we want to round off the final answer to 3 sig figs. And the units there, because moles of phosphoric acid cancel, is moles of hydrogen. Okay. Let's take a look at the other ones. Here we're interested in oxygen. So from the chemical formula, we know that there's a subscript of a 4. Okay, a 4 right there. So we want to convert that to moles of oxygen. There's 4 moles of oxygen here. So we set this up again. We're starting with a quantity of 2.00 moles of H3PO4. Okay. And we set up our fraction bar. We want the 1 mole of H3PO4 to be on the bottom of this fraction, so it cancels, right? And on the other side of the fraction, we have 4 moles of oxygen. So we would type in 2 times 4, but we would want to write the final answer to 3 significant figures. And don't forget to write in the very careful units of moles of oxygen. Now for C, we've got phosphorus. All right, phosphorus. So 1 mole of this chemical is equal to 1 mole of phosphorus. Now the reason why is because there's technically just a subscript of 1 there that we're not showing. Okay, so that's where we're getting the 1 from. And we want to set up the dimensional analysis once again. We're starting with 2.00 moles of H3PO4. Okay, fraction bar. On the bottom, we want 1 mole of H3PO4. And on top, we have 1 mole of phosphorus. Now, we're not going to grab our calculator and do this on our calculator because calculators can't work with units, but we're doing the work here to show you how the moles of H3PO4 cancel, and afterwards you're left with moles of phosphorus. Okay? If you want to make a lot of money, invent a calculator that can do math with units. Now for part D, it looks a little different, okay? It almost looks like part B, but we want moles, not moles of oxygen, but atoms of oxygen, okay? So we're going to start with this quantity right here, because we already did part 1 of that. We know that we have 8.00 moles of oxygen, okay? And we want to somehow convert that to atoms of oxygen. All right, how do we do that? Well, the first thing you need to recognize is that 1 mole of oxygen is equal to 6.022 times 10 to the 23rd atoms of oxygen. And that's called Avogadro's number. Now, to set up the math, we take 8.00 moles of oxygen, okay? And once again, set up your fraction bar. 1 mole of oxygen needs to be on the bottom of this fraction to cancel. And on top, we're going to have 6.0 times 10 to the 23rd atoms of oxygen, okay? And that's going to be equal to, we have to use our calculator here. And we want to round this off to 3 sig figs, so significant figures. So we round this off to 4.81, I'm sorry, 4.82 times 10 to the 24. And be careful of the units. We want to write atoms and then what chemical? Oxygen, okay? So I hope that these problems help you understand chemistry better. If you like these videos, please consider subscribing. Have a great day.